Hello and welcome. This is the Asylum, and today I'm joined by my friend Derektionary, and we're going to bring you a little video about the Zpordle, a really interesting math game that even I need a little help figuring out. So Directionary is going to help us try to do that. So Directionary, why don't you go ahead and take it away?
Yeah. Well, thank you for having me, the Asylum. I really appreciate it. So hi everybody. My name's Derek Shakes or Derek. I really don't mind. Um, and uh, and yeah, I want to talk to you about Z Portal because a little bit unfortunate, right? A couple days ago, I looked up Z Portal on just a random website trying to get it, and I got poodles. It's not a well-known variant of Wordle. Um, I'm assuming because it's a bit mathematical, but hopefully you're watching this because you want to learn about it. And it's not super complicated. It's really not. So let's go ahead and get started on it. So let's figure out what Z Portal's about. So you need to know a couple things, like a couple prerequisites before. First off, we need to know, say that we have a number. Okay, it shows up nicely. That's good. And say it's an integer.
Would you like me to show your tablet?
Yeah, if you don't mind.
Yeah, it's showing.
Cool. Okay, so let's say we have a number n. It's an integer. It's positive. So like 1, 2, 3, 4, whatever. Um, and now we're gonna start off with something that might sound a little complicated, but I promise it's not. So let's define something called the p-adic norm. Hopefully no one dropped yet. The p-adic norm of, I mean that sounds complicated, right? The p-adic norm of a number n. Okay. Uh, all that this is equal to. This is equal to 1 divided by p to the m. Okay. So I'll explain what p and m are. So p is equal to a prime number, just a given prime. So it can be like any prime that you want. And then m is equal to the number of factors of p in n. All right. So another way to so this is basically saying that p is a prime, and you're looking for how many times p goes into this big capital number n. All right. Another way to phrase this, and I will use colors. The colors really don't mean anything. So if anyone's colorblind, it's totally fine. It's really just to emphasize different points. So another way to phrase this is that p to the m divides n. All right, so it's a number smaller than n, and it divides it. But p to the m plus 1 does not. So like you have like the most amount of p's dividing n. But if you put one more p on it, it doesn't. So just as some examples, because I'm always a big fan of examples whenever I'm learning math or teaching math. If we have an example here, say n is equal to 6, and let's just say p is equal to 2. If p is equal to 2, then we can talk about, say, the two-adic norm. I don't know if that's actually how you say it, but I say the two-adic norm. So p is 2 here. And we can ask, what's the two-adic norm of 6? So basically that's saying how many times, how many twos go into 6? Only 1 2. Fun fact, only 1 2 goes into 6. So we would say that the p-adic norm is equal to 1/2. And this is because, shorthand for the word because, probably use it a lot, only 1 2 goes into 6. All right, so the two-adic norm of 6 is 1/2. All right, let's do p equals 3. All right, why not? Three-adic norm. Well, only 1 3 goes into 6 as well, so this would be 1/3. And it's for the similar reasoning, right? Because and I'll say it a different way now, right? Because only 1 3 is a factor of 6. Okay. What about p equals 7? Right. Just keep going with some examples. What's the 7-adic norm of 6? Well, you might be like, well, can we even talk about the 7-adic norm? I mean, the 7 doesn't go into 6, right? So like 7-adic norm, like that doesn't make any sense, but it does. I mean, it's fine. The 7-adic norm would just be 1, and it's because there are no factors of 7 in 6. So basically, this 1 is saying it's 1 over 7 to the 0 power, right? So m is equal to 0 there. So there are no 7s in 6.
That
So
just made a whole bunch of sense. Thank you,
yeah.
Derek.
Hopefully a lot of these hopefully a lot of the aha moments are going to come up with people in the audience and with you. So 7 to the 0, that's equal to 1. 1 divided by 1 is 1. Yeah. So that's super cool. All right, well, let's do a more complicated example, right? All right, let's get a little crazy. Let's go 24. Lots of factors in 24. I'm just gonna spill out what these norms are. So 2-adic norm. Feel free to pause the video, think about it. Hopefully I get it right. It's 1/8, and it's because that 2 to the 3rd goes into 24, but 2 to the 4th, that's 16. That doesn't go into 24. So 8 is the highest, like power of 2 in a sense, right? 3-adic norm is what, 1/3? Because there's only 1 3 in 24. What about the 4-adic norm? Well, I'll let you think about this.
Is there a 4?
That's a good question, right? Oh, the thing is, 4-adic norm, that's not a thing, right? It has to be a prime, right? So that's what I said in the beginning, right? You need P to be prime. Not a thing. Being sneaky here. Not a thing. All right. So you have to have a prime norm. Otherwise, it's not well defined, right? Because you could talk about like other stuff, but yeah, like primes are like the building blocks of numbers, right? So you gotta stick with primes. Okay, so let's talk a little bit about Z-Portal. So that's the background. That's all you really need to know about the background behind what a p-adic norm is. Other parts of Z-Portal will be like mainly algebra. I mean, it's gonna be like kind of, it's not like intense algebra, but it's a lot to at least think about in your head. So yeah, so that can make it pretty confusing and pretty obscure, but it is a lot of fun, this game. So let's talk about this game. So Z-Portal, you might ask why it's called Z-Portal. It's called Z-Portal because there is this field of numbers called ZP, and those have the norm of p-adic norms. So if you want to look up fields, this is a common field ZP, and it's a lot of fun to work with. So let's do Z-Portal.
I can get some in there for you. Hold on. Yeah.
So Z-Portal gives you.
I'll be right back, Derek. Keep going.
Okay, no worries. Just making sure. All right, guys, we're away. I'm gonna take over the Asylum's YouTube now. No, I'm just kidding. So Z-Portal gives you a lot of primes. All right, so this is how it starts. So if you go to the Z-Portal website, and I'm sure it'll be in the description, I'll let the Asylum know. It starts by giving you a list of primes, okay, in the beginning. So it gives you, oh yeah, I shouldn't say maybe a lot. I should say a list. That's me not reading my own notes. It gives you a list of primes. And your goal, you are trying to guess a number between 0 and 1,000. All right, so you're trying to guess a number between 0 and 1,000. And as clues, to help you through it, as clues, the game gives you the p-adic norm, which we've talked about, of the difference, all right, of the difference between your guess and the secret number. And we're going to go through some example games that basically I made up. Between your guess and the secret, there it is, number. So let's just get started. So let's say that I want to use different color. Let's say that they start with p equals 2. So you go to the website, you type in a number, it's going to give you the 2 norm of the difference between your number and the secret number. So let's say let's start with p equals 2 and say we guess 313. Okay, that's cool. Just random number. We're going to guess. We're going to say, hey, secret number is 313. Let's see. And it spits out the two-adic norm. It says two-adic norm is equal to 1. Now, it's giving us the norm of the difference between our guess and the magic number. It's not giving us the norm of 313. I mean, okay, it actually is, because 313 is odd, and so it doesn't have any powers of 2 in it. So the two-adic norm of 313 actually is 1. But the main point here is that it's not giving us the norm of 313. Because, like, how is that going to help us get the secret number? Like, if we type in a number and it's like, oh, the norm of that is 1/2. We're like, okay, great, but like, I don't know how the secret number is, right? I mean, I could literally pick any other number. So it is giving you a bit more information than just that. It's giving you the norm of the difference between our guess and the secret number. So what does this norm of 1 mean? Well, this means that the secret number, I'll just refer to it as that. Yeah, it's x away from that the secret number is x away from 313, where x has no factors of 2. So in other words, what does it mean for x to have no factors of 2? Well, that just means x is odd. Okay, so in other words,
n is even.
X is odd, and so n is even, right? So it means that we're an odd distance away from 313. So if you think about adding an odd number to 313, like the assignment said, you're going to get even numbers. So this tells us that we're even. So we guessed the wrong like parity, right? Odd even parity. But that's okay. So we just guess an even number. Now you can just guess any even number you want. You don't have to be near 313. I mean, you got 0 to 1,000 to work with, right? So you don't have to be super near 313. But you want to, add 1 or add 3 or add 5 or subtract 5 or subtract 3, subtract 7, whatever your heart desires. We are going to add 3. So I'm going to say we want, just to super explain it, we want to guess a number an odd distance away. Hopefully my handwriting is legible. An odd distance.
Fine.
An odd distance away from 313. So let's guess 316. So I'm not doing any strategy here. As I go through, actually, these guesses are gonna really jump around. And it might seem like it's kind of silly, but I'm just trying to explain some numbers here. Let's guess 313. Okay. Well, let's say so remember they had this list of primes in the beginning, and they have these 10 primes, and for each of your guesses they're going to give you that p-adic norm. So the first prime, there was a 2. Let's say the second prime is also a 2. Let's not make it super hard. That'd be like terrible if the second prime was already something different. So let's say p equals 2 still, and let's say that now we have a two-adic norm of 1/4. Okay, so what does this mean? So this means, well, I'm gonna write it. So This means that the distance x now has a factor of 4 and no other factors of 2. So now the distance between 316 and the secret number is a multiple of 4, right? But no other factors of 2. So it's not like multiple of 8 or 16 or whatever. It's only a multiple of 4 and like no other 2's. So we can express that as like an algebraic quantity. If we want to be fancy, use some big words there with Q. We can express this. So express x as x is equal to 4k, right? And something a little bit special about k is odd. All right, if k would have been even, then x would have like an 8 in it. Right, it would be divisible by 8. But we know that it's only divisible by 4. It only has a factor of 4, no other factors of 2. If it was 8, if it had like a factor of 8, then this twoadic norm should have been 1/8. Okay, so 4k where k is odd. So our next guess, I'll switch some colors, spice it up. Our next guess should be 4k away from 316, and k is odd. K is still odd. So you could do like a cute little number line here. Right, so we got 316 right here. We could go to 320. These aren't going to be like in like the correct number of steps. I'm just going to write some numbers in. We could add 12, 328. We could add 20, 336. We could subtract 4. 4 times 1. We could subtract 4 times 3. So this is plus 4 times 1. This one's plus 4 times 3. This one's plus 4 times 5. We could subtract. Right, you have all these options. I just want to show you kind of what's going on, right? Basically, all right, the arrows are going to be everywhere because I want us to see all of them. That was 4 times 3. So yeah, right. So you could add 4 times 1, 4 times 3, 4 times 5, 4 times 7, 4 times 9, yes. Right, and then you could subtract 4. You could subtract 4 times 1, 4 times 3, 4 times 5, all that stuff.
So, Derek, we are going to need to restart the meeting to have your tablet.
True. Okay.
In 10 minutes. So, unless we can finish up your tablet in 10 minutes and then just go to a single person, maybe that'll work.
No, the tablet's going to be a bit longer than 10 minutes.
Okay.
Unfortunately. So should we like stop here and do a new meeting right now, or should we use up the 10 minutes?
Let's go ahead and stop and restart right now.
Okay.
So everyone, we're going to sorry for the little break in the video Discord, the video discontinuity. We're gonna have to restart our Zoom meeting. Back in a minute.
All right. Well, welcome back, everybody. So where were we? We were basically looking at multiples of 4 away from 316, odd multiples of 4 away from 316. And like I said, you can choose whatever one you want. Doesn't really matter, right? Just have some fun with it. But I do just want to pull out this little fact here. So it wouldn't be a cool math talk unless we proved a fact to ourselves. So let's do a fact. If we continue with this algorithm, which is like, doing like 4 times k where k is odd, or like 8 times k where k is odd, or 2 times k where k is odd. If we continue with this algorithm, we will always get a a better norm. So we'll get more powers of 2 in x. All right, so like if we were to, you know, add 4 times 3 or something, like the next guess won't be 1/4 anymore. It'll be 1/8 or 1/16. And it's like guaranteed. Like you'll never get the same norm twice if you do it right. So we can prove that to ourselves quite quickly. I think it's a little cute proof. So why? Well, let's say we choose 316 plus 4 times 5. All right, so let's just go with that. And the answer, maybe the answer, we know that the answer is an odd multiple 4 away. So let's say the answer, maybe not was, maybe is. And the answer is 316 plus 4 times, I don't know, 39. Okay, say that was the answer. We guessed 4 times 5. So if we guess that, so if we guess 316 plus 4 times 5, our new, so by guessing 316 plus 4 times 5, our new x will be x equals, it's going to be the difference between these two numbers, right? 316 plus 4 times 5 and 316 plus 4 times 39. The 316s will be in the same, so when we take their difference, the 316s are going to cancel, and we're really just focused on x will now be 4 times 39 minus 4 times 5. A little bit of arithmetic. You can pull 4 out, who knew? And you get 39 minus 5, and you get 4 times 34. And so now this 34, this has a power of 2, right? 34 is divisible by 2. So that power of 2 is going to join with its friend 4. And this is going to be 8 times 17. And now our new norm will be 1/8. So that's why that you're guaranteed it, because, you know, if we choose 4 times an odd and the answer is 4 times an odd, their difference will be 4 times an even. And that even will merge with the 4 and will get you a better norm. So that's the little proof as to why you always acquire another power of 2. So we acquired another power of 2. We could have acquired more, like power of 4 or something, but we'll always acquire at least a power of 2, one power of 2. So we should always do this algorithm, right? Always do this algorithm. All right, so let's go back to the problem. So we're at 316. The 2 norm is 1/4. Let's not do 5 times 4. I don't know why I didn't do it in my notes. So let's guess. Oh yeah, I wanted to guess a negative, because you can totally do minus stuff. So let's guess 316 minus 1 times 4. Okay, and that'll be 312. Let's say the p equals 2 still. So again, right, there's this list of primes at the top of the website, and it has 2s, 3s, 5s, 7s, whatever. And let's say that it starts with 2. The second prime was also 2. The third prime is also 2. Let's go with that. Let's get p equals 2 still. 312, the 2 norm is now 1/8. All right, so you're saying, well, Derek, we started at 313, if you remember. We started at 313. What if we just subtracted 1? We could have gotten right to 312 and right to 1/8. Well, yeah, sure, you could have. Right, we didn't. Right, I mean, like, we don't know, like in advance, like that 312 was going to be better than I think than 316 or 320 or something. Or yeah, better than 316. We didn't know, so no biggie. All right, so now we have 1/8. So now let's play the same game. Now we know x is equal to 8k, where k is odd. And now we add 8, subtract 8, 3 times 8, 5 times 8, 7 times 8, whatever. But now I want to inform you on stuff that the game does. Right? The game can switch primes. Right? I mean, like I was saying, right? It was at 2 for the first 3 guesses, but the game can switch primes. So what do we do then? So, what if the next prime is p equals 3? Maybe with a question mark. What if the next prime is p equals 3? What do we do? Well, we stick with the algorithm, all right? It does not affect our guess like right now, right? The fact that the prime is changing to 3, we still do this 8k thing. So stick with the algorithm. All right, so let's guess 312. That was what we were at, yeah. 312 plus 1 times 8. That'll put us up to 320. Now, it doesn't give us the 2 norm now, all right? We know the 2 norm is going to be better, and I'll talk about that. I have it written down. Let's say the 3 norm is equal to 1. Okay, so the 3 norm is equal to 1. A key thing is that we don't know the 2 norm. We do know that it will be better, right? We know it's going to be better. So like 1/8. No, 1/8 actually just happened. So yeah, better than 1/8. So 1/16, 1/32, 1/64, etc. But we don't know which one, right? But we know it's going to be better, and it doesn't have to like skip like in ones every time. So okay, so what do we do now? So let's go back to the k that we chose. We chose k equals 1, right? We did 8 times 1. There it is, 8 times 1. And we got a 3 norm equal to 1. So that means that the distance x is not a multiple of 3 away from this 320. Okay. Now, how can we use that for our algorithm? Well, for the algorithm, all that means is that we just have to focus on this k value now. Okay, that's the main thing we have to focus on. So this means that we should choose k odd still. And k should always be odd because of that 1/8 norm that we got. So k should always be odd, but not 3 away from k equals 1. All right. We don't want to choose 3 away from k equals 1 because if we do, that's a multiple of 3. And we got a 3 norm of 1 saying that our difference should not be a multiple of 3. So we don't want to choose like k equals 7. Right? K equals 7 is 6 away from 1. And that's a multiple of 3 away from 1. So I should actually say a multiple of 3.
Yes, thank you. That confused me for a second.
But not a multiple of 3. All right, it should not be a multiple of 3 away from 1. So, well, it shouldn't be 3 away from 1 either, because 3 away from 1 would be 4, and that would make k even. So, like, that's also bad. All right, we want to stick it to be odd, but not a multiple of 3. So we don't want to add 6 to k. We don't want to make k equal 7. We don't want it to be 13, right? Or we can go negative, right? We don't want it to be certain negative numbers, like -5, right? -5 is also 6 away from 1. So don't want to choose -5. So what we can do is we can write out the possible values of k. So I'm going to write out all the odd numbers for k. Well, not all of them. It's kind of a lot to write. So I'm going to start with maybe -21. And I'm going to go down the list. Oops, missed one. -15, 13, -11. These are all the possible values of k that we can choose. 1, and then my notes change pages. 3, 5, 7, 9, 11. I only go up to, okay, I go up to 23. Right. Counting odds with Derektionary in the Asylum. Do you know your odds? So, all right. So obviously we're not going to guess k equals 1 anymore. So that one's out. All right. But we also don't want to guess a multiple of 3 away from k equals 1. So like I said, 7, 4, right, is not there because that's even. So we don't already want to guess that. 13, 19. We can go backwards, -5, -11. Just subtract 6. That's all I'm doing in my head. -17. So those ones we don't want to choose. So getting a norm equal to 1, it doesn't give you no information. It gives you some information, but it's not like super great. But it does eliminate some of the primes, which is awesome. Or some of the odds, I'm sorry, which is awesome. So let's guess. Let's go back to guessing. If you notice, we go back to the 312. So we're going to go back to the, let me actually put that first. Go back to 312 and guess. There could be a way where you actually use, I think we guessed 320. Yeah, we guessed 320. There could be a way where you start with 320, but I always go back to the last like power of 2 that I got. So 312 was my last power of 2 guess. And I stick with that. And it covers all the bases. There's nothing extra that I'm doing. So that seems to be good. And seems to be like the easiest way for me to explain it. So we go back to 312 and we guess. So let's guess 312 plus 8 times what? I put -1. Did I? Yes, I did. So that gives you 304. So now we have a 3 norm of 1/3, maybe. All right, let's say we get a 3 norm of 1/3. That's pretty cool, right? It's always better to get like a lower norm. Like that's great. Norm basically means distance away from the number, just for any norm. And so you always want a norm to be small. That's the point. That's why that these norms are 1 divided by p to the n, because norms in general are small. Like whenever you're close to, 2 numbers are close to each other in a certain norm, you're supposed to be small. So, okay, so we got a 3 norm of 1/3. So that's really good. That means that actually this -1, we are a multiple of 3 away from -1. So now we want to choose multiples of 3 away from -1. So like 5 or 11 or 17 or 23. So now we actually want to choose those ones. So having a norm of 1/3 eliminates a lot more. But it's actually even more. It's actually even more than just that. So, so now, hopefully people are still with you. I wonder how many people dropped. I'm gonna say probably half. Maybe not half. Who knows? So now k needs to be odd. All right. It needs and forgot the and it needs to be a multiple of 3 away from -1. Now, I'm omitting some information right now because there actually is more than just that. But let's get the ones that are 3 away from -1. So k equals from here, we're going to pull the ones that are 3 away. Let's see. This multiples of 3. This, this. Backwards is this. -6, -6. I already did the 19. And I'll put -25 as well. Because that's a multiple of 3 away. So I'll write them out. So we have -25, -19, -13, -7, -1, 5, 11, 17. I wrote it out a lot. 23. The pattern is you just keep adding 6. Okay, so that's all I'm doing. I'm just adding 6 to these numbers. Because I'll stay with an odd number. If I add 3, I go to an even number, and we need k to be odd. So I'm just adding the next multiple of 3 from 3, which is 6.
Thank you for that.
Yeah. This 35. La la la. Okay. So these are the possible k's. Of course, we have a bunch of dots. All right, it could be super negative or super positive, but there's actually more than this, which is kind of frustrating because maybe now people are going to drop because it's complicated. We don't. Well, okay, let me write it because I have it written. So, but you don't want k to be a multiple of 9 away from -1. Now, why? Well, that's because we had a norm of 1/3. If we were 9 away from -1, we would have had the norm 1/9. Right? So we don't want multiples of 9 away from -1. We want multiples of 3, but not of 9. And yeah, I mean, I use a notepad almost always when I play this game, mainly because I do it in the morning and I need a notepad because I'm not really focusing. Or I'll use like Wolfram Alpha. But I've turned to using a notepad because I think it's for me it's a bit more exciting when I figure it out and I'm like, oh cool, like I got the right K or whatever. So we don't want to be a multiple of 9 away because if we were a multiple of 9 away from -1, we would have had 1/9 as the norm.
And so, similarly, we don't want to be a multiple of 127 or of 27.
Yes. So we also don't want to be a multiple of 27 away from -1, but that's equivalent to being a multiple of 9, right?
Okay, yeah, that makes sense.
Right, because if you're a multiple of 9 away, you move 3 9s away. Now you're multiple of 27 away. So
okay, yeah.
So you don't have to. So that's nice, right? You don't have to keep looking at powers of 3. You can stop at 9.
Okay, cool.
Which is really nice. Yeah. All right, so we don't want to be a multiple of 9 away from -1. So this 17 here, that's not going to be good because that's 18 away.
Yeah.
Right? So we don't want to guess 17. I put in 35 for this reason. 35 is 36 away from -1. We don't want to guess 35. So it gives you more information, actually. It's pretty cool. We don't want to be -19 because that's 18 away from -1.
Mm-hmm.
So that's all. But hey, it's something, right? It takes away some stuff. Of course, we're not going to guess -1, right? We already did. That would be silly. Okay. So that's good. All right. So let's go. Let's move on. And let's guess. Well, here, let me put in words. You don't want to be multiple. Otherwise, the norm would have been 1/9. Okay. All right. So let's guess one. I used blue recently. Let's guess. We're sticking with our 312 plus 8k. 312 plus 8 times. What do we want to pick? I chose 5. And calculator. Well, I guess that's only 312 plus 40. That's not super bad in your head. 352. All right, we did the 3 norm again. We get 1/3. Okay, well, that's kind of weird. So I put on here. All right. We just had a norm of 1/3. How can we get norm 1/3 again? I mean, we did the algorithm correctly. This video is going on YouTube. So something's going on here, right? Why didn't we get 1/9? All right, why did we get 1/3? Because with the 2 norm, right, it always got better, and I proved that. I proved that it always got better. So, isn't it supposed to get better? Obviously, the answer is no. It's not supposed to get better. It gets better with the 2 norm, but yeah, not with the 3, unfortunately. So, no. What's the side face? No. Only for p equals 2 is it guaranteed to get better. And to convince you, I just wrote a little example that I'm going to share with you. Right around halfway done. So I don't know. Yeah, hopefully we won't need to do another Zoom meeting. But hey, who knows? Hopefully this is making sense to everybody. I can't actually say if you guys have questions, interrupt me. But comment, I guess. I'll respond. So guaranteed, yeah, to get better. Yeah, okay. So why? How come? All right, if you're not convinced, let's do an example. Suppose the answer is 312 plus 8 times 29. Okay, so suppose 29 was the k. I'm just going to scroll up. 29 was one of the little k's in there, right? So let's just suppose it was 8 times 29 plus 312. Well, bullet points, -1 is 30 away from 29, and 30 is a multiple of 3, and it's not a multiple of 9, so that's good, right? So 30 is 3 times 10, so multiple of 3, but not 9. So that's good. And then also, what was our last k? We guessed k was 5. That was our k. So is 5 also a multiple of 3 away from 29? So 5 is 24 away from 29, and 24 is 3 times 8. Yeah, so it is. So it's not. So we're not guaranteed that if we choose a different k, now we'll have 9 times away. So both of these were both 3 times away from the answer. So you can have a situation where you don't necessarily get a better norm, but it still tells us information, and I'll explain that. So 24 equals 3 times 8. It is a multiple of 3, but not 9. So yeah, so you can have 1/3 2 times in a row. Now, once you get 1/3 2 times in a row, I'm pretty sure the next time you have to get better, 1/9 or something, I think. And you can think about why that's true. But a cute thing that is definitely true is you'll never get worse. That's good, right? So if you have 1/3, you're not going to go back to norm of 1 if it's done correctly. You won't get back to norm of 1. You'll stay at 1/3 or better. So that's always good, right? Okay. All right. So that's okay. This still helps us. It still helps us. So it still helps. So how does it help us? Well, so our k is very constrained now. So I'm going to list out the properties of this k, which is why notepads are good for this variant of Wordle. So our k is very constrained now. We have 312 plus 8k. And we know a few things about k, 3 things. 1, k is odd. Hopefully we've convinced you on that. We do not even look at even k's. Okay. That comes from the 1/8 norm. 2, k is a multiple of 3. Oh, wait. Well, yeah, I put it in. That's fine. Multiple of 3 away from -1. And I put in here, but not 9. And then here, same thing, but for 5. K is a multiple of 3 away from 5. And again, just as a little side note, but not 9. All right, so hopefully it's making sense. So, I mean, are there any Ks left in the world that do this? I mean, like, this is really restricted. Like, but yeah, there's like a buttload of them. So, okay, so what Ks are left? So, so starting at k equals -1, we want to add / subtract 6, right? I mentioned, right? So you can always add 6 or subtract 6 from -1. You can always add or subtract 12 from that. You don't want to add or subtract 18 because 18 is a multiple of 9 away from -1. So I'm going to skip that. So after 18 is 24. We could add or subtract 30. We don't want to add or subtract 36 because 36 is a multiple of 9 away. We could add or subtract 42, 48, so on, ... All right, we could add or subtract that. Make that ... better. But we also need to be sure that these k's are multiples of 3 and not 9. Away from 5. All right, so it's a lot. Let's write some out. So let's start with k equals -1. Add 6, subtract 6, add 12, subtract 12, add 24, subtract 24, la la la. So let's just talk about adding. So we're going to add 6. That's a possible k. We actually use that one. Add 12, add 24, add 30. And yeah, okay, I'm just going to keep adding 6. 35, 41. How high did I go up? 47. All right. Or we could subtract. We could subtract 6. Subtract 6 again. Subtract 6 again. Again. Yes. Made a little bit of boo-boo. I am going too fast here. We don't want to subtract 18. So we subtract 6. Yeah, I did go a little bit too fast. This 35 shouldn't be there. Fun fact, right? Why shouldn't this 35 be here?
Because it's 36.
Yeah, exactly. Look at me. I'm just adding 6 this whole time. I'm like, I'm not going to look at my notes. 41, 47. Okay. And now we subtract 6, subtract 12. We don't subtract 18. We subtract 24. We subtract 30. We subtract 42. We subtract 48. Okay. But now we eliminate the ones that are 9 away from 5. Now eliminate ones. These will all be multiples of 3 away from 5 because 5 is in this class. So these will all satisfy the fact that we are 3 away from 5, a multiple of 3 away from 5. So
I
let's
was
eliminate.
just about to ask that.
Yeah. So these all will be multiples of 3 away from 5 because 5 is one of the numbers. So we are good.
Okay.
Like we're adding 6.
Okay,
and all
that makes
stuff.
sense now. Yeah.
But we want to make sure that we're also 9 away.
Yeah, I get the 9 part. I just didn't get why we're guaranteed to be a part 5 away yet. That makes sense now, though.
So eliminate ones that are 9 away. I do see the timer ticking, but let's actually try to use up some of this time as much as possible before we go to the next meeting, if that's cool.
Yeah.
Eliminate ones that are 9 away from 5. So basically, none of these are going to be actually 9. I keep forgetting to say multiples of 9. Multiples of 9. Because none of these are going to actually be 9 away. Because being 9 away would mean that k is an even number. So we're multiples of 9. It's like 18 away. So is there something that's 18 away? I think so. I see a 23. And we don't want you. We also don't want the 5, of course. Let's see. What if we add? Yeah, I think that's why I put 41 in here. 41 is 36 away from 5. We could keep looking up higher, right? But let's go lower. So let's subtract 18 from 5. So negative 13. That's not allowed there. Minus 36, negative 31. That's not allowed there. Minus 49 is not allowed here as well because that's 54 away from 5. 54 is a multiple of 9. So don't hesitate to get calculators out with this stuff. I mean, if you really want to play it, hey, why not, right? It's super fun. You guys already do everything else, right? You might as well put on Zpordle on your little list. Impress people. So, all right, so this is our list. So I'm gonna actually write out this list, and I'm gonna put a few more negative numbers, and I'm gonna put a few more positive numbers, so that we can see stuff. So let's do k is equal to, we have ... So I'm gonna put the next negative. It's negative 61 happens to be. Negative 43, we see that above. Negative 25, we see that above. 7, 11, 29, 47, 65 is the next one. ... Now, I want to ask you guys, feel free to pause the video if you want to. Well, don't pause yet, haven't asked. Do you see the pattern? Is there a pattern in these Ks? Right? This is mathematics. Mathematics is all about finding patterns. Okay, that's 100% what math is about. It's about finding patterns and learning how to extrapolate certain patterns. So, do we see a pattern with these? The answer is hopefully yes. Asylum, do you see a pattern?
No.
It's okay if you don't. Okay, that's fine. Let's kind of look at these differences here.
That's what I was starting to do, but it just didn't click.
Yeah, how do they all differ by? Well, I think the easiest ones to look at are these two, just because like they're like the smallest numbers. So negative 7 and 11.
They are all 18.
Yeah, they're all 18, aren't they?
They are all 18.
So that's cute, right? All right, math is all about patterns. All right, so apparently this comes out to being all multiples of 18. Now, someone can explain why it's exactly all multiples of 18. I mean, I might have explained why that they're all multiples of 18 by doing this really long list. But yeah, I mean, so that's cool. I don't know. They're all multiples of 18. It does make sense because we want k to be odd. So the differences between the two successive k's are going to be an even number. And the even number is 2 times 9. And it's 9 because we've gotten the 3 norm twice. Or 1/3, I guess, twice. So that's a little bit why. That's a little bit of motivation as to why. So let's do this last guess because this last guess has us win because this is just a made-up game. So I was like, well, now let's probably win. Why not? So let's go back to 312 plus 8k, and I chose negative 25. I don't know. I'm just doing random numbers, right? It doesn't super matter. 312 plus 8 times negative 25, and we get 112. And say we win. Say that we're still on a 3 norm. We could be on a 5 norm or anything like that. Whatever norm. We get 0 and we win. I don't want to box that. I want to box the win. So 112 happened to be the magic number. All right. So whenever you are at the magic number, the difference between you and the magic number is 0. Now you can think about what's the 3 norm of 0. Well, how many times can 3 go into 0? It can go in a bunch of times. You can divide 0 by anything. 0 divided by 3, divided by 9, divided by 27, whatever. So in the P norm, you'll have like 1 over 3 to that power, but that power can be super large because you can divide 0 by any power of 3. So you have 1 divided by a super large number, and that's essentially why that you get like 1 divided by infinity, and that's equal to 0. So the norm of 0 is equal to 0. That's kind of the proof of that. But yes, so we win. So I think now is a good time to do a new Zoom call. I just have a few more things left, some strategies and a summary. So let's try to do a new Zoom call. How's that?
All right. We will be back in just a second. Sorry for the interruption.
Thanks for staying, you guys. You guys are crazy. Well, welcome back, everybody. So we just won. Right? That's pretty cool. So this is kind of how the game works. I'm going to give a summary of this game right below. So let's go back and check. So our first guess, if you recall, it was 313. Right, way long ago when we had no idea what this game was. Right now we have a little bit of an idea. We had 313. Let's take a look at 112 minus 313. Let's make sure that the norm is actually 1. We get negative 201. Well, I think the 2 norm is equal to 1 on that one because there's no 2's that divide 201. The negative doesn't really matter. Like negatives don't affect if a number divides you or not, just in general. Okay. What about 316? That was our next guess. They're like, oh, well, let's just increase by 3. So 112 minus 316. We get negative 204. We look at how many 2's go into 204. Apparently 2 of them do. 2 norms equal to 1/4. Yeah, I think it's 4 times 51. So that checks out. And then we decided to guess 312. So we would have 112 minus 312, which is negative 200. Now that I know is 8 times 25, because I think of 200 as like $2, and then like how many quarters do you have? For $2, you have 8 quarters. That's how I think about that. So 200 is 8 times 25, and so 2 norm is 1/8, which we had. Next one we guessed was 320. $112 minus 320. We have a negative 208. Now we didn't know what the 2 norm of this was. I didn't write it down either, but it's better than 1/8. And I don't. Maybe it's divisible by 16. 16 times 13, maybe. Yeah, probably. I don't know if it's probably, but it's a maybe. That's for sure. But we got the 3 norm. If we divide it by 3, it's not divisible by 3. So we got the 3 norm 1, if you remember. We did some more math. Figured out, hey, let's go with 304. Yeah, let me just make sure I have that right. Yep. So let's go with 304. And 112 minus 304 is negative 192. I know that that's 96 times 2, but what do we get? We get 1/3 for the 3 norm. So the 3 norm here is 1/3. Again, we can divide it by 3. We get 64, I think. So yeah, so it's only divisible by 1 of 3s. It's not divisible by 9. Guess 6. We guess 352. And so 112 minus 352, negative 240. And the 3 norm was still equal to 1/3. You can divide 240 by 3, you get 80. 80 is not divisible by 3. So only 1 power of 3 can go into 240. And then on the 7th guess, we guess 112, and we won. Yay. Doesn't matter what the norm was, it would be 0. It would give you 0. All right, so let's recap a little bit. Let's maybe look at some strategies, because if you look at these numbers, they're like really bad, because like 313, and then we went up 316. There. Went up 316, back to 312, went up to 320, and we like barely moved from 313. Barely moved. But like, sometimes it'll be like that, where you barely move from a number and it gets you a way different norm. All right, that's very, very common. So first off, I just want to say that this is a lot to remember. Yes, you are right. You are very right. It is a lot to remember, right? It is very solid. It is tough.
I've been taught it 4 times now, and I still.
It's still tough, right?
It's still tough.
I do it every morning, and I'm so nervous that I added a multiple of 3 wrong, and I'm like, I don't want to get this wrong. Yeah, it's tough. There are other math-based Wordle games, right? I mean, I use Mathler a lot. Mathler is fun. They have an easy, a medium, and a hard website for Mathler. Nerdle is very popular, though I don't use it as often. But this game is one step up. P-adic norms are very interesting. I learned about P-adic norms when I was in PhD school. Like, it's not something taught in like undergrad or something. But they're not super bad to learn. Like, they're not. But no one teaches them. Mainly just because of applications. P-adic norms have applications that are mainly in research, graduate school and stuff. So application wise, it wouldn't make sense to teach it for undergrad, but it's not super bad. So okay, well let's look at some strategies. Let's finish off with some strategies. I really only have kind of 2 strategies, I think. At least that I can think of, because I can't really think of any other strategies. So strategies is there a starting number to use? Fun fact: when I started this, like when I did Zpordle for the first time, well, let me tell you this. For the first 3 times I did it, I was getting norm of 1/4 and then a norm of 1/3. I did not use those. I did not know how 1/4 and 1/3 interacted with each other. I had no idea, and I literally guessed on those, and used Wolfram a lot. So yeah, like the first few times, you will definitely forget to do something. Like one of the Ks you'll accidentally use, and you'll be like, oh darn, go to a different browser, try it again. But with practice, you start to get a hang of it. So until recently, I was actually always starting with the number 112 or 111. I don't know why. I think it was because it was a small number, and so I could increase my Ks, and get into the 800s and stuff. If that happened to be the magic number, I could get up to 800 within 10 guesses. I don't think I mentioned that this game has 10 guesses only. But sometimes if I started with 112, the answer would be 7. And so I'd be searching higher and higher and higher. And then the answer is 7, and I should have subtracted instead of adding all that time. So there are some disadvantages of it. But I was like, well, it's small enough where most of the numbers will be bigger than 112, right? But yeah, so So I always start with 112 or 111, because I wouldn't know if it was an odd or even number. So I would just guess each time. Um, but I recently changed, and it's because of someone else who this Asylum and I know goes by Panthera. She used to start with 500, and now she starts at 0. So she always starts at 0, and then she does this case strategy. Her strategy might be a little bit different, but basically she increases to the next viable number, to the next possible number. So then that way you don't have to worry about subtracting. You just add, and you get all the numbers. You don't skip any numbers. Like what if the number was 5 and you happen to skip it? So like she won't skip any numbers. Now that might be an issue if you do if the number's 900 something. Um, but yeah. So that's one strategy. Let me just write that down. So if you want less confusion, start with 0. Now she starts with 0. Now I don't want to start with 0. I mean, mainly because she took it. Because actually that's a really good starting point is 0. So I actually start with 1,000. So I start with 1,000 and I go negatives. So I decrease to get. So I decrease all my numbers, in the smallest increments possible. Sometimes I'm tempted, if I have a bunch of Ks and I have only 3 guesses left, I want to jump. I want to be oh well, I'm never gonna get through all these Ks in 10 guesses. I want to jump, but I haven't, and it's been working pretty good. So I'd say start with 0 or 1,000. So if you want less confusion, that way you don't have to worry about should I add, should I subtract. It starting with the highest or the lowest number, it says okay, I can only add, or okay, I will only subtract. I'm not sure which one is better, and I was thinking about it last night actually. I did some programming. I did some very I basically did no programming. I mean, I did a couple of functions here and there. I don't think one's better than the other. I don't.
I think 0 is more intuitive. I think it's easier to add than it is to subtract.
Yes, I completely agree with that. I think it's easier to add up to the number than to subtract down from 0 or from 1,000. But yeah, if the magic number was 900, my path would be the same path as if you started with 0 and went up to 100. Right? So 900 and 100 have this similar. So yeah, I don't think that one is better than the other. I don't. But 0 seems to be better because these last couple of times 0 has been done in less steps. I won't say for today's what's going on, but for other days 0 gets it done in less steps than 1,000. But yeah, but I haven't lost with 1,000. I think I'm at 95% accuracy or whatever, and I think I've lost maybe 2 or 3 times. Probably just the beginning ones, or maybe I started on a new browser. Who knows? Yeah, I mean these work, but they do have their limitations. So I'm gonna go through one example, one using the 0, one using the 1,000. Okay, and then we'll call it quits for today. So let's do one example. I'm gonna give you the list of primes. And yeah. Oh, I have one more sentence here that I said out loud. That way, you only need to
worry about one direction. Yeah.
Exactly. Guess larger. Not of or smaller numbers. Yeah, it takes a little bit of stress off of you. But now hopefully after you've watched this, or maybe you just skip to the strategy section if there's a timestamp, maybe now you know why it works, right? And that was the whole point of this, is to show you why that it works. I mean, like I could give you this strategy, I could tell you what to do, but if you're not gonna know why it works, that's not as cool, right? You gotta learn why. It's fun. You can teach other people. You can sound super smart at parties. I do that very infrequently, But sometimes I'm like, sometimes people are like, oh wow, Derek, that's so cool. But they know I have a math PhD. They know what I'm like. So okay, so let's do a list of primes. Let's do a fake Zpordle game. Zpordle. I don't know even how to say it. Let's say that the primes given were 2, 2, and yeah, and so they give you the primes like straight away. Like it's not like a mystery. All right, they give you the primes straight away. Maybe that'll help you. I don't know how it would be helpful. 2, 2, 2, 3, 3, 11, 17, 17, 17. 23.
That should be 10. That's 10 right
Oh,
there.
is that 10? Oh goodness. 3, 4, 5, 6, 7, 8, 9. One more.
One more. Okay. Yeah.
23. Okay. These do not help you out. All right. Like, completely ignore those. Like 2s, 3s, and 5s. Those are your friends. So if you get a 7 and your norm is 1/7, that's like miraculous. That's awesome.
That sounds like instant knowing the number, right?
Exactly. Like it's super good. But yeah, 2s and 3s are gonna be your friend. Like if you get 11 or 17, you get 1/17, or like 1/17 squared, like 1/289. You take a picture of that. You send that to me on Discord. All right, that is amazing. You frame that. All right, you frame that right now. That's incredible. So okay, so let's say we have that. All right, and I'm gonna give you the secret number right now. So secret number 603. Made it up a few nights ago. All right, so let's do the 0 one. So we start at 0, and I'm giving you this primes. I'm saying start at 0. Feel free to try them out before I do them, right? Because there's only going to be one path. So I start at 0. 2 norm is equal to 1 because we have an odd number. So I'm going to say here we're going to. What's that?
Right, we add 1, right?
We add 1, exactly. Yep. I'm just going to write out the case. 1, but the strategy here is to choose the smallest viable k.
Right.
But I'm just going to add them so we know what's going on. Okay. Different color. Add 1. Different color. 2 is 1. All right. What's this 2 norm? Well, luckily they'll tell you. We don't have to calculate it. That's nice. 1/2. What it looks like from my notes. And so we add 2k. So k is 1, 3, 5, 7. So we should add 2. That's how it works. So we're at 3. 2 norm is 1/8. Cool. So we add 8k. K is 1, 3, 5, 7. So we add 8. So another like reason why this is really easy to memorize is that you always just add this number. Right? You just add like the denominator. This is technically divided by 1.
Mm-hmm.
Just add the denominator. Right? With powers of 2. When it's not powers of 2, it's not. I don't think it's that. We'll see. So we add 8. Okay. Get 11. 3 norm. Now, because the prime's different, is 1. That's a bummer. Okay, so now we guess 3 plus 8k. Now, k is not a multiple of 3 away from 1. So now we start when k is equal to 3. So k equals 1 is not right. 5, 7 is not good because that's 6 away from 1. All right, so 7's not good. So 3, 5, you just skip 1. 9, 11, skip 1. 15, 17, skip 1. But yeah, if you're only doing the smallest k, you don't have to worry about the next numbers. But I'm just trying to show you what's going on. Okay, and so we add. Oh, Well, we don't actually add here. I put it in here. I put 3 plus 8 times 3. That's the next guess. So what is that, 27? Now, obviously, so this secret number I made up after I made this path, right? I made this path first, and then I was like, what do I want the number to be? Because I wanted certain norms for you to see. So this norm is 1/9, which is pretty cool. So what does this mean? This means that we guess 3 plus 8k. But we are a multiple of 9. A multiple of 9 away from 3. All right. So that's really nice because if we add 3 to 9, we're at 12, but that's even, right? We don't want even, we want odds. So we actually add 18 to 3. And so our smallest k now is 21. So that's really cool, right? So when you get 1/9, it's really powerful. So our smallest k now is 21. And like I said, you don't have to worry about the next k's if you're going to do this strategy, but I'm just going to write them out for you. So the next k value is 21. We add 18 again, that's 39. We add 18 again, that's 57. Now, it's not going to be 57. And it's because of this extra constraint where we have to be a multiple of 9 from 3, but not a multiple of 27 from 3. Because if we were multiple of 27 from 3, we would have had 1/27. So 57 is actually 54 away from 3, which is a multiple of 27. So it's actually not going to be 57. Right, but like I said, right, you really just didn't want to focus on the first k if you're going to do this strategy. But I wrote some out just to be fun. 75 and 93. So it really starts shooting up pretty fast. So yeah, 1/9 is a nice one to get. So let's do 3 plus 8 times 21. We do that, we get 171. Now we're on to the 11 norm. Okay, at this point, you'll almost always get 1. Just keep doing the k's from above. And that's why it might be good to write them out. Because once you get higher than 7, you'll probably just stick with the same algorithm that you had. So yeah, so this is no help. I mean, basically, you don't want to be a multiple of 11 away from 3, but like you won't. I mean, these numbers are like already pretty restricted. Being a multiple of 11 away from 3, I'm pretty sure none of these numbers even are, unless you're already past 1,000. So yeah, like you typically don't have to worry about these. So we're going to say k equals 39, 75, 93. And actually, past 93,
Aren't
the
we above
number,
1,000?
yeah, past 93 actually, the next number after 93 is 108. And 8 times, oh wait, no, maybe it's 128. Oh no, sorry. 111 is already 108. Yeah, I can't read my handwriting. That's fine. But yeah, the next number is going to be too large. It actually will push this number above 1,000, past 93. So we don't even have to do it. So I'm just writing down those 3. So what do we want to guess? We want to guess 8. No, 3 plus 8 times 39. And what's that? 315. 17 norm. Forget about it. It's going to be 1. So I mentioned here, keep guessing. The k's above. Yeah, so yeah, that 57 didn't work. We can kind of go with this game. that every third number, right? If you look at these numbers, 21, 39, 57, every third number is going to be canceled out. So the next number after 93 is going to be canceled out. And I have a feeling that that's equal to 111. Yeah. So that's going to be canceled out. And then the next one is 129. So K equals 75, 93, 129. But actually this number already puts you over 1,000. All right, that number puts you over 1,000. If you multiply it by 8 and then you add 3 to it, you're above 1,000, so it's not going to work. So what's nice here is actually we're about to be on guess 8. We only have 2 other Ks we have to check. So we know we're going to win, right? Because we have guess 8, guess 9, guess 10. And we have 2 Ks. So we know we're going to win for sure. That's always a nice feeling. So let's do just the next one. Let's not skip. 3 plus 8 times 75. And what do you know? That's 603. And we win. Okay. So that's how that game works for 0. So the last one, I'm going to start with 1,000 and go negative, just to show you a little bit how it's different. Because you do get different norms. And we'll call it a day. So yes, I start with 1,000. I'll have to start censoring my Z portals now because right, if you start with 1,000, you can see the colors. You know exactly what I guessed. You can see the norms. You know exactly what happened. So, or we could start at 1,000, and let's do that. 1,000. Oh, let's put 603 here, just to remind ourselves. Well, it's right up there. I don't need to put it. It's right here. So 2 norm is 1. Now we subtract K. 13579. Go brown here. Subtract 1. Now we're at 999. 2 norm here is 1/4. I don't think it was that last time. I think it was 1/2 last time. This one, maybe it was 1/4. I think. No, yeah, it was 1/2. Yeah, so you get different norms, right? No biggie. So we subtract 1/4. Or sorry, norm is 1/4, so we subtract 4K now. K is 13579. And we're going to subtract 4 now to get 995. To get 1/8. We subtract 8K. And we subtract 8. And yeah, subtraction is harder to do in your head. Like I do think 0 is kind of a more natural place to do. Or you could always spice it up, well, start with 603. Hey, you win, right? So, I mean, you don't have to start at these. 995. Okay. So we're going to subtract 8. Yeah, 987. So now the 3 norm. 3 norm is actually 1/3 right away. So it's pretty cute. So 3 norm is 1/3. So we're going to guess 995 minus 8K. Now we do want to be a multiple of 3 away from K equals 1. So the next one will be 7. That's going to be our next one. 7, 13. We don't want to be a multiple of 9 away. So I'm not going to put 19 because that's 18 away from 1. So not 19. So 7, 13, not 19. 25, I'm just adding 6. 31, not 37. I'm skipping that one. 43, 49. Put 61. I'm really putting a lot in my notes. 61, and so on. All right, so now those are the Ks that we want to do. Oops. So we're going to do 995 minus 8 times 7. And we get 939. 30 norm is actually also 1/3. Right, so we don't get better. But that doesn't stop us. We're going to guess 995 minus 8K. Now, K is a multiple of 3 away from 7 and a multiple of 3 away from 1. So 13 still works. But now this 25 is no longer good because that's 18 away from 7. But we only want to be a 3 away, like a multiple of 3 away from 7. We don't want to be a multiple of 9 away. Otherwise, we would have had 1/9 here when we guessed the 7. So I'm not going to put 25. 31 is still good. 43, I don't think I want to put 43. 43 is 36 away from 7. 49 is still good. I don't think I want to put 61. No, I don't. 67 is still good. ... So we get those numbers now. So we do 995 minus 8 times 13. And now, unfortunately, I think now we're into the 11s and the 17s. So these are the Ks that we have left with to play, assuming like 11 and 17 aren't going to do anything for us. Typically won't. If you look at that and you compare it to these, all right, we actually had a lot fewer options with the 0. 21, 39, 75, 93. I mean, you're already up to 100 basically on the Ks after 4 of them. After 4 of the Ks, you're basically up to 100. With here, after 4 of the Ks, you're up to 67. And that's because of that 1/9 norm, right? When we went through that 0, we had 1/9 as the norm. And 1/9 was super powerful. Here we have 2 1/3, and it's not as powerful. So, what is this number? 995 minus 8 times 13, 891. And 11 norm, it's going to be 1. And for that, we just keep going. So just to list out the K values, possible K values. 31, 49, 67. There are a couple more that we could still do, frustratingly. 103, 121 only. So those are the only K values that we can still do. But if you notice, we just did guess 6. We have guess 7, 8, 9, and 10. We have 4 more guesses, and we have 6 more Ks. So here is a chance where, skipping around might be helpful, because we're not going to be able to guess all 6 Ks. We can only guess 4 of these K values. But I'm going to keep going in order. But here you start to get a little bit nervous, right? You're like, oh no, I might not win. 8 times 31. But then, if you guess one of them, that could have been the answer, So there's this trade-off, right? You don't know what's going to happen. You just got to be careful. So with this one, this is 797. What did it say? 747. I probably did copy some of these algebra things wrong, but that's okay. All of it's from my notes, and they're small because I wanted to fit them all on 2 pages for my printer. So I squeezed them in, because like these notes, when I export them, it exports it as one PDF page. So you just have a really long, thin PDF page of notes. So it's a bit annoying. So I think this was 747. Yeah, let's go with that. 17 norm, forget about it. It's 1. I checked. It is 1. So keep going with these. 8. We do 995 minus 8 times 49. That actually might be it, because 8 times 50 is 400. So we subtract 400 from 995, we get 595. So it's probably 603. It is. Yeah, 603. And we win. Yay. Did I put win up here? No, just a star. Oh, okay. So yeah, or last thing I want to say before I head out. It's good timing too. We're about to leave. So so we would have lost with k equals 103 or 121. So just keep that in mind, right? It just so happened that with this one, we might have lost if we didn't skip. All right. And last thing I want to say is you can start with any number you want. All right. It totally doesn't matter. You could have started with 602 and then added 1. You would have gotten 603. So hopefully this game makes a bit more sense now. I'm not saying go out and play it. I'm just saying, maybe now you know some stuff about math. You know some stuff about how p-adic norms work. You can explain it to someone else maybe if you really want to. I'm always reachable on Discord. And yeah, my name's Derektionary right there. So yeah, definitely reach out to me if you want. Leave a comment. And anything like that. And I just want to thank the Asylum for allowing me to use his YouTube to explain Zpordle, so I don't have to make one video on my YouTube account.
Oh, you're very welcome. I'm glad to do it. This was a lot of fun for me, and hopefully a lot of people learned a lot. I learned a lot, so I'm probably still not going to play it, but
I don't blame you. It's all good. I don't hate.
I'm just not a math guy.
No, you're fine. You're fine. I mean, the main thing is that a lot of this mathematics is understandable. That's the important thing, right?
It is understandable. Absolutely.
That's the key. I'm not saying go out and do it, but I'm saying that lots of, and I do believe anyone is smart enough to understand this, right? Doing it daily, you don't have to. I don't care, but I think learning math, anyone can definitely learn this stuff.
Yep.
No one should shy away from learning it. So I'm glad no one is. Hopefully, we have a little bit of an audience here.
Absolutely. I hope so too. And I thank you very much for taking the time to do this.
Yeah, of course. Yeah. Thank you for having me.
Awesome. Well, we're gonna call it here, folks. I'm gonna have a lot of fun editing this down. But hopefully we'll, like you said, if you have any questions, you can reach either of us on Discord. The link to the Sudoku Solvers Discord, where we both hang out, is in the description. Furthermore, you can leave a comment here on YouTube. We'll both see it, and if he doesn't see it, I'll be sure to relay it. So, thank you again, everyone, and we'll see you again later.
Also, you'll put the Zpordle link in the description.
Oh, the Zpordle link will, yes. If you want to play, the link to Zpordle will be in the description for sure.
Because it's hard to find Googling. Honestly, you get poodles. Yeah, and you're like, do you mean poodles? I'm like, no, I did not mean poodles. So.
Yeah, no, the link to the game will definitely be in the description, along with links to the Discord server we hang out in, so you guys can easily get in touch with us. So thank you again, Derektionary. I really appreciate it.
Yeah,
Thank you everyone for sticking in through this nice long video. Hopefully you learned something. I did, so it's been pretty fun.
All right, guys.
Thanks. Bye.
See you all.